This topic, and topic is entropy, which is represented by delta S. And what do we call it? Have you ever heard of this word before? Entropy is word. In very simple words, मैं इसकी बहुत keep things very simple for you. And what do I say is that it's a measurement of disorder of the system. What is entropy? Entropy is the measurement of the disorder of the system. This is the most simplest version of how entropy looks like. What else or what brief you should be knowing about it? हम ये भी कहते हैं about entropy that this is the number of possible arrangements. Arrangements of the particles and their energies in a given system. See, let's suppose that someone has given me 4 books or 5 books or maybe 10 books. 5 कर लेते हैं. One way to arrange those 5 books is like this. And the other way of arranging those 5 books is like this. So this is A and this is B. What exactly is the difference can you observe in both of these arrangements? What is the difference? Okay, you're saying arrangement is different. My question would be how the arrangement is different, and you're saying that more space. Okay. Random. Where you can see the random arrangement. B. Okay. The answers from the other side. What do you think? What is the difference? Right. Instead of random, there is another word which you can use. Very right, Abdullah. No, it's not. You can understand how it works, but I'm going to connect it only with chemistry, no maths. Yes, the ones who are saying the regular or irregular arrangement, the ones who are saying random or organized, yes. The word which you should be knowing is that this arrangement is very organized or systematic. And this is a disorder. And remember, if there will be more disorder, then the entropy will also be more. If it's more organized or maybe less disorder, then automatically it will have less entropy. Because entropy was what? Entropy was the measurement of disorder. So the more system will be in disordered form, in disconnected form, in disorganized form, the more will be the entropy. Are we clear about it? Is there any question? Awesome. If there is a question, you can ask me. Or if you're done, shall I move on to the next slide? All right. So the next part is, now the question is that let's suppose if there is an increase in entropy, right? As we said, हमें एक बात समझ में आ गई, if there is an increase in entropy, then we say that that means the system is more disordered. What about the energy? Will this system be energetically stable or unstable? That would be my question. So how the system is, it's energetically stable or unstable. मैंने आपको क्या scenario दिया? I've given you a scenario that there is an increase in entropy. And when I say there's an increase in entropy, that means the system is more disordered. And when the system is more disordered, then my question would be that how the system is it energetically stable or it's not stable? Okay, Muhammad Ayan, point taken. Haris is saying unstable, point taken. What else? Why you are saying it's stable? Disorder है तो सिस्टम है एनर्जी का ऑर्गेनाइज स्टेबिलिटी होती है ऑर्गेनाइज में एंट्रोपी ज्यादा होती है डिसऑर्गेनाइज उससे एनर्जी का क्या लेना देना है एनर्जेटिकली मोर स्टेबल होगा या नहीं पोटेंशियल ज्यादा होगी और ज्यादा काइनेटिक एनर्जी ज्यादा होगी डिसऑर्डर ज्यादा है पोटेंशियल ज्यादा होगी Okay. I will take it from your point. Very good. You have given me a point. You said more energy. Am I right? And let's suppose we are saying, for the sake of saying, because you've said it, and this can be one of the scenario. You said that here in this scenario, they have more energy and they have more, if we become more specific, they have more kinetic energy. That's what you are saying? They have more kinetic energy. That is why they're poles apart from each other and they are more disorganized. Now tell me one thing. More energetic state is a stable state or unstable state? Question is from everyone. Okay, great. So in unstable state, can molecules be at one space or be at one place? That's my another question. They cannot be at one place. When they cannot be at one place, they are at one place. The only thing is that they are disorganized. So are they energetically stable or unstable? And I would say one more thing. Let's suppose कि आपके पास there is one thing. Let's suppose this is carbon. Here it has A and B, right? Put it this way. And here I have one carbon. Here this one is A and this one is B. Which structure looks more organized and which structure looks more disorganized? This is structure number A or this is structure B. Which structure looks more organized? Which structure was disorganized? A looks more organized. This structure looks more organized. A is more. Which one is more stable? Why? कह सकते हैं आप. This is A, this is B. हमने इसके बारे में ये suggest किया that this structure looks more organized. Then we said this is A and this is B. Or maybe I can make it more a little unstable to just look at that way. And I said this look more unorganized. Then I asked you that which one is more stable and which one is Less stable. Stable की बात करेंगे, which one is more, which one is less? This is again, the question is from everyone. Which one is energetically more stable and which one is energetically less stable? Why A is more stable and energetically? How do you know that this less energy? Let's suppose कि मैंने इसको हीट किया, I wanted to break the bond. मैंने इसको भी हीट किया, I wanted to break the bond. When I heated this one, I needed only 20 kilojoule per mole of heat. But when I heated this one, this needed 70 kilojoule per mole heat. So which one was energetically more stable? So B was energetically more stable. हालांकि अगर मैं देखूं तो B was unorganized. Can you come up with any reason that why B was energetically more stable? And this is an actual scenario. Okay, you said shape. What does the shape do to make things more stable?
अगर हम इसको 3D उसके अंदर देखें तो सबसे ज्यादा दोनों में अगर हम 3D ओरिएंटेशन में देखते हैं
मैं इसमें एक और कॉन्सेप्ट लेकर आती हूँ। इसमें एक और कॉन्सेप्ट ये था, हम ये कहते हैं कि जिसके पास 3 मॉलिक्यूल्स होते हैं या 3 एटम्स होते हैं, जनरली उसकी शेप कैसी होनी चाहिए? लीनियर होनी चाहिए। यही हमारा कॉन्सेप्ट था। बट जब हम वाटर की बात करते हैं, वाटर की शेप लीनियर नहीं होती है। यस, वेरी गुड, अच्छा लगता है, दोनों को इतना अच्छा याद होता है। सो इसकी शेप लीनियर नहीं होती, हालांकि इसके पास भी 3 है, इसके पास भी 3 है, लोन पेयर्स है इसके पास। तो हमने बेसिकली क्या कहा था? हमने कहा था शेप बेंड तब हो जाती है जब वो अपने आप को ऐसी पोजीशन पे या ऐसे सिमेट्री के ऊपर लेकर आता है जहां पे लेस फोर्स ऑफ रिपल्जन होती है। जब वो लेस फोर्स ऑफ रिपल्जन के ऊपर लेकर आता है तो वो इसको क्या देता है? मोर स्टेबिलिटी देता है। दैट इज वाई जब इस बॉन्ड को हमें ब्रेक करना होता है देन वी नीड अ लॉट मोर एनर्जी। Did you get the point or you did not get the point? In this case also, why this unorganized one is more energetically stable? Because these things, they have positioned themselves at a place where they are symmetrically comfortable. That is why they are more stable. जरूरी नहीं है कि if they looks very good, they seem very good, they are energetically also very stable. No, that's not important. Generally in chemistry, what you will see, I'll give you another scenario. Let's suppose I have CaCO3, calcium carbonate. Calcium carbonate has a potential, and has a potential to do what? It has a potential to decompose. When I heat this, after heating it, it will change into what? Calcium oxide plus carbon dioxide. What do you think? Which part is more stable now? Calcium carbonate was more stable, or calcium oxide and carbon dioxide are more stable? ज़्यादा stable compounds कौन से हैं? Calcium oxide and carbon dioxide. They are more stable as compared to calcium carbonate. But which part of the equation is more organized? This part of the equation is more organized. Why it looks more organized? Because there is only one compound over here. And they must be arranged in a specific shape, in a specific orientation. However, when it comes to this part is less organized. When this part is less organized, then what do we say? We say that here we have more entropy. Here we have more entropy, but energetically, they are more stable. So what did you conclude out of all of this? Everyone, what did you conclude out of all of this?
हाँ बेसिकली हमने ये किया कि एनर्जी से कोई फर्क नहीं पड़ता बेसिकली उसकी जो अरेंजमेंट होती है जो एक प्रॉपर मैनेजमेंट जैसे
Less organized compounds are more energetically stable. What did we conclude out of this? We concluded out of this that if a system is disordered, then what do we mean by this? We say that it has more entropy. And what else do we say about this? We say that more entropy means energetically more stable. Please bear in mind when we say energetically more stable, we do not mean that a molecule have 20 kilojoule per mole energy or a molecule have 40 kilojoule per mole energy. No, that's not what we meant. What we mean to say is that if we want to bring a change in the system, then for that particular change, how much energy is required? If a system is requiring more energy, then that means it was more stable energetically. If a system is requiring less energy, that means the system was less stable. Yes, then you can link on to the concepts as well. There is another example. Let's suppose you have water. Okay? Now water is in the solid form. The other here is in liquid. What if I tell you that water has to go under state change? Who will change the state more quickly in no time with less amount of energy? Very good. Solid change quick. A quick change will happen from solid to liquid. However, if you want to go from liquid to gas, how much temperature is required? 100 degrees centigrade, which is a lot more energy. Then who is more stable energetically? Who is more stable energetically? Liquid or solid? Liquid. More stable energetically. But who is more unorganized? Sorry, who is more organized? Solid. But this one is more organized. Who has more entropy? Liquid. Thank you for participating. You are participating. I am noting down your answers, and this is really important. Now just write it for your own learning point of view. This system with the higher entropy will be energetically the more stable or the most stable because the energy of the system is more spread out. When it is a disordered state. This is the conclusion of all what we are discussing this right now. Let me know when you're done writing with this. Should I move on to the next slide? All right, if you're done with this, then my question would be, I'm putting the question on the. My question is, which state of matter has higher entropy and why? I want you to give me an answer of 3 marks and also please write down some keywords into it. Quickly.